What's up? It's Raphael with an update. So, you guys are looking at a blank screen with a really nice design here. So let's put something on that screen. Let's see here. So this is what I call my to-do list for my 2D game engine project. Uh, so here is what describes what all these things mean. Uh, So anyway, usually when I implement a feature, I check it off here. I put an at on it. Just because it's checked off, of course, doesn't mean that that feature is complete. It just means it's implemented into the 2D game engine, but it's not necessarily complete. I don't think anything will ever be complete because I don't want to get into the thought that, hey, this works the way it's supposed to. No, I always want to have a mindset that that there's always room for improvement. So this will be an ongoing project for a very long time, and it's just fun to work on it. That's the reason I'm doing it. It's just a ton of fun to work on it. Uh, So you can see here I've implemented several things: the sprite class, the back buffer, the sprite grid layers, the tile map, bitmap class, the viewport class, developer mode, background class, player class, flipbooks, radio message, object linking, route, a ton of stuff. And all of this has taken about 6 months of just because I usually design something and then I tinker with it, then I make it better and I keep at it and I keep at it. And I sometimes I may go back and change things around because I don't like the way they work. For example, here, sprite layers was replaced by sprite grid layers. Back then, the way I rendered sprites on the viewport was I cycled through a very giant list of sprites, uh, and then I checked to see if those sprites were actually in the viewport to display them. What ended up happening is as the game engine got more detailed and I started making ridiculously large levels, I found that it was affecting performance because now we were rendering thousands of sprites and we were cycling through this gigantic array. So that was affecting performance, and I had to sit down and said, well, how do we just display the sprites that are actually on the screen and completely ignore the ones that are not? What if we didn't have to check to see if an item was in the viewport? What if we just went exactly to the location in the array, displayed the sprites that we needed, and could just quit? And I found a way to do that, and it was through tile maps using a special formula. So then that sprite layers got replaced with grid layers, which tremendously improved the performance. I don't know if you saw the last video, but the performance is so good that the game is incredibly smooth. I mean, it feels like if you just played this, you'd think it was a DirectX game, but it's not. It's just straight up Windows GDI. It's just that I've sat down and I've gone through the code hundreds and hundreds of times, making sure that I'm only putting enough in there to squeeze every ounce of performance out of this thing. Because we're working with the Windows GDI. The GDI is really not that great for games, but if you're careful in the way you implement something, you can get some really great performance out of it. You can see here I had a stage manager. That didn't work out very well. The whole deal with the stage manager is I don't even know if I have. I don't even know if I have. Yeah, I do have documentation, but the whole idea with the stage manager is that it was a class that stored how many I don't know how many sprites a level had, the starting position of the sprites, what background to use, and eventually all that stuff got replaced by the viewport, and I just completely abandoned the stage manager because it was complex. There was a ton of code in that thing, and it just wasn't working out. I had a collision system class, but I didn't like it because it was very slow. And the way it worked is every time we had a game cycle, the collision system would go through every single object and it would try to see if they were colliding with each other. Now it worked, but it was extremely slow, because if you've got 1,000 sprites, that means you have to cycle through 1,000 sprites. So if you got 3 sprites on your screen, no, if you, let's say you had 1,000 sprites, okay, so the collision system would take that sprite and then compare it against the all the other sprites to see if they were colliding. Then it would descend down to the next one, and it would repeat the same thing again 1,000 times. So it would go through every single one, and it just wasn't working. So what I ended up doing was I implemented that system into the sprite class, so that when a sprite is moved, it does its own collision checking, and that, man, that set performance through the roof. So there really isn't a collision system in my 2D game engine. It's just really it's the sprites that they do their own collision. It's kind of a hybrid, because it's implemented into the sprite class, and it's also implemented via the, I believe, the object. Let's see. Let's go to our project here real quick. Let's see right here. You can see right here in update objects. You can see this is somewhat part of the collision system here, because we're looking down to see if there's an object there, and we look up, we could look right, we look left, and now we're just looking for objects to react to. And you can see that there's a couple of things in here. If we detect certain conditions, like the player getting crushed, here, this is how we detect the player getting crushed. And a couple other things will eventually be implemented here. This will eventually blow up. Usually when it blows up like this, that is my cue that tells me, hey, this probably needs to be a class. The idea is, how do we make it a class? So it might be, I don't know, but for now it's going to remain like this, and depending on how large it gets, I may or may not turn it into a class. So let's see what else we got here. Bitmap class, Viewport class, developer mode. Developer mode, see how it says it's implemented? Well, it's not fully implemented. There's still a ton of features that have to be, and this whole developer mode thing, this will not be available in the actual games. This is something for me so that I can edit the 2D maps. Background class, I think the background class, there's a couple of, I might add some features into this class for example, for certain tiles. I don't know, I may just add it to the tile. May just add that feature to the tile grid class. Right? And the idea is that if you load a special function, you can do pattern backgrounds and stuff like that. I think that would be really neat to put it in there. Player class, flipbooks. Flipbooks are basically animations, radio message system, object linking, object triggers. Anyway, what we're going to talk about here is what are we going to do next. So you'll see exclamation marks here. These exclamation marks mean that this particular item is being researched. That usually means that I'm getting ready to implement it. So a ton of research has to be done to see how it's going to be implemented. What changes do we need to make to the game engine, and how do we adapt it? Because we don't want to just jump in and start writing code. I usually do just rough draft first, and then I implement that into the game engine, and we kind of just get it working, write some raw code. So as you can see here, I'm by no means complete with this thing. This list usually grows in size. It may decrease, it may grow. So nothing. This is not necessarily everything that I'll be implemented, but it's still a fairly large. As you can see here, all this stuff at the bottom, GUI. If you don't know what that means, it means a graphical user interface. So in a game, sometimes it'll have menus and dialog boxes with screens that to let the player change settings and stuff like that. Um, so if we want to have a custom mouse pointer, that would be really nice. A class that handles menu selection, check boxes, that's pretty easy to do. Input boxes, buttons, message boxes, a game overlay. A game overlay is basically the stuff that shows the player score and any lives they might have, or anything that basically just sits on top of what is being rendered. Sits on the That would be called a game overlay, and that's like an extra layer. That's why I don't want to add any more layers, because this is yet another layer that has to be rendered on top of the game. So the more stuff you pack into that scene, the less performance. I mean, we have enough layers right now that we could really affect performance, but the idea is that less is better. The less you cram into your game scene, the better. The features are there to go really, really crazy, but generally you don't want to go crazy. You just want to put enough in there that you just want to put enough that whatever you want the player to see in that specific scene as the player's moving through the game map. You don't want to just cram a whole bunch of stuff in there, because it's gonna drive people's eyes crazy. You'll see here alpha blending. This is another tricky thing. We can do alpha blending with but for example, for water, there's a part of the water. For example, if we have like a little bit of water, the top of the water has to be transparent. And I haven't really tested transparency with alpha blend, and well, actually I did, but there's that part. I'm talking about the alpha channel that makes it whatever's in the behind that bitmap to be see-through. I don't know if that makes any sense. Like, for example, here, let's launch the game engine and let's show what we're talking about here. Let's see. Let's use a particular. We're gonna go here and select a particular. For example, this thing. Do you see these holes in here? This is called transparency. It's see-through. Of course, it's see-through. The other type of transparency is blending, where an item is, like, for example, this box here is translucent. It's partially see-through. So when you move it over things, it shows itself, but it's kind of just faded away. It's kind of like transparent. Well, the water effect would be something like this, but then we have to find out how to make the top of the water so that it's see-through, like one of these blocks, and not just translucent. So for that, I need to use an alpha channel. The thing is, I don't know if that's going to work with the way the Windows GDI handles bitmaps, because for the alpha blending to work, it has to be 32 bits, and the bitmaps are usually 24 bits. So that's changing the bitmap, the bits. So I don't know if it'll work, but I have to try it. The sucky thing with that is that you'd have to make a separate sprite sheet for the water. So I'm gonna have to get really creative in how I implement this, but I'll get it done. Let's see. So that's being researched at the moment. The fading from black, I'm not going to talk about that. I just want to talk about what's the full screen mode was tested before, but it's not yet fully implemented. This can be implemented fairly quickly. It's kind of implemented right now, but it's being researched because we need to have a setting. For example, when we go up here, of course, here I decided to call my game engine Chaos FX, and I actually make these awesome looking Axie art through this web page right here. That's why I put it there, to just give them credit, just remind myself. If you want to contact me, there's my email. Let's see. Okay, so when we scroll down here, we have a couple of settings. All this stuff will probably ultimately be a big structure, um, and we will call it game 2D something. So that way we can create that structure and just be able to get access to all of these settings on the fly. So for that, what were we just talking about? Oh yeah, for the full screen mode, we need to have a setting in here that says what type of mode we are in. So that would ultimately be some kind of string. I don't know, but that you can see that that's why it's being researched, because I don't know how I want to implement it. So grid object zoning, kind of a mouthful, but the idea with grid object zoning is that, here, let's talk about this for a bit. Let's launch the game engine. All these sprites that you see here, they're all part of a grid. The ones that are not part of the grid are, let's turn off the, this item here is not part of the grid, and neither are the spikes. And neither is this thing right here, this little moving platform. These things are referred to as objects. And right now they are rendered through the old system, which was the sprite grid, the sprite vector class. And the more objects we add, the larger that vector, the larger that array gets. So if we had like 1,000 objects, we have to cycle through 1,000 objects to see whether or not they're in the viewport. So that's going to affect game performance. So that's where grid zoning comes in. So let's say that this specific object just sits here. Some of these objects don't move, but when they're on the screen, they do, for example, the spikes here, they are constantly checking the distance to the player to see whether or not they should calculate whether or not the player's there. These things are also measure the distance to the player, and they turn themselves off and on. For example, if the player walks far enough away from one of these objects, they stop animating, they stop checking. That kind of improves engine performance. But the next step to improving that performance, so that we can have 1,000,000 objects. For example, we would not be able to have 1,000,000 objects, because we would have to cycle through 1,000,000 objects right now to check all of them. But with grid zoning, what that means is we make a separate grid for the objects, and this grid will be the size of the map. Now, not all objects will use grid zoning, but the idea is that the ones that do, for example, this object can use grid zoning, the spikes can use grid zoning, the moving platforms can use grid zoning, some enemies that will be in the class can use grid zoning. Of course, if it's an enemy that follows the player through the level, we can't use grid zoning for that sprite, because it's there. But I don't know, we may be able to use it, but that's something that we can implement down the road. So the idea is that when the game is first launched, we take all of the objects in the game. Every object has a specific zone, basically a rectangle. It just defines a rectangle in the grid, and it says, hey, this is where I live in the 2D map. So for this particular platform right here, it moves up and down from 413 to, I believe, 913. So this sprite would claim all of these tiles on the grid, and it will say, hey, I live here, 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 and here, here. Now, it may not be here, but when we're moving across the level, and because we're going to be checking just a specific area, And as soon as we read that grid, we read the grid to see what objects we can or cannot update. So when we come across this object, it says, well, a moving platform lives in 413. And then the vector, the index to that area that belongs to that specific object will be in that grid. That's it. That's all the grid is going to have. It's going to say, hey, there's something there, and whatever is there is actually the index of the object that lives in that section of the grid. So with that information, we add that object to the list of objects that we can update and render. So essentially, we're generating a list of objects so that we can choose which ones we want to render. So that will improve performance when we have like 1,000 objects. Because instead of rendering 1,000 objects, we probably only have to render maybe 10, 13, maybe 15. That's nothing. That will eat up absolutely no cycles at all. So that hasn't been implemented, but I believe that is the first thing that I need to implement, because it's game engine specific. It belongs to the way the game engine operates. So, but I need to research how I'm going to do it in the most efficient manner. The other thing is, so that's grid object zoning. And the whole idea of that is to improve game performance. So we'll have that imaginary grid that will not be visible. It'll just sit there. So, that may just be a separate class all on its own. So that's what I need to sit down and figure out. And then we might just incorporate the object layer into that class so that we can only render whatever is in the grid at the specific time. So if this feature was implemented, this specific sprite here that's going up and down, if we were right here in the game, it's no longer visible. So that platform, it's going to disappear from the list of objects that we can check for collisions and stuff like that. That's the whole idea, is we still have to do collision the old-fashioned way with objects, and that will improve performance by reducing the size of that list. The other way we do collision checking, and I know that this will work, is when the player sprite is walking, see how it's resting on the level here? We're not checking all of these sprites to see if they're there. The way I implemented this is the player requests a vector. Let's see here. Let's go to the code real quick, and that pertains to this part. So right here, this little function, get vector at grid. So we get a vector at grid. In this particular item, the object 0. Yeah, it gets a vector at the grid from this particular object right here, the object 0. This should be the current player, but we have it set like this for now. So it takes the dimensions of that sprite and it creates basically a little square about this size. So instead of checking all of these sprites for collision, we only check the ones that are actually in close proximity to us. That makes the list shorter and it improves performance, because we're not going to be checking this for collision. We're not going to be checking that because that's nowhere near us. We're not going to be checking this because that's nowhere near us. But once it goes inside, then it will be in that list of vectors. Let's see. And right now, we do that for the maps, for the sprites that are on the 2D map. We don't do it for the vectors, but once grid object zoning comes in, we will be using that function to actually, reduce the size of this vector so we can only check those items for collision. Anyway, so that's getting confusing, but let's move on to the next feature that I plan to implement. Let's see, object data parameters right here. The idea with object data parameters is every object will have a string of data. So normally I used a function that got x, y, the width, the size, the position, blah, blah, blah. And these functions ended up having a ton of arguments on them. And the code looked extremely ugly. Now, I actually have the functions that did that are completely grayed out because, like I said, I completely changed the way that the game engine operates. So these functions automatically became obsolete. So I had to disable them. But you can hear in this grayed out text, this is how we loaded the maps. We created a function, basically took a bunch of data that was in zeros in a specific format, and then we loaded that data from each one. And of course, here we have here saving the map too. So you can see how involved this is huge. This is a lot of steps to save a map. So that's all the stuff that we had to do to save a map to a file, because we didn't have that feature data parameter. So the idea is that every object will be able to load its own parameters and save its own parameters. So if we were loading a map, we wouldn't have to do any of this stuff. We would just add, we would just cycle through an array, of course, and we would use a function from that sprite to get the data, and that particular function would feed us the data to populate the array. And then if we were saving to the map, we would do the same thing. Well, we would request the information, which would be a string, and all we had to do was just copy the string to the file. So back then I used a lot of zeros, but I think this time I'm just going to stick with just separate everything by commas, and then just let a function will parse and read through the individual commas and then read the data. So that's it. That's a rather simple feature that will improve saving and loading maps, because that way we'll have everything on the sprites. Let's see. Oh, what's next here? Bitmap title selector. This is the next one. Let's go back to the game here, which is still running. So what the bitmap tile selector is, we have two modes here. We have paint mode. When we're in paint mode, this is called, this little thing that I can move around, it's called the tile holder, or my paint bucket. If I hold the mouse and click, I can paint with it. I can add sprites there. And if I play, the player will interact with those sprites, and he won't be able to jump out there, because now I've added sprites up there that we can interact with. And if you wanted to jump on the top, this is why this is so much fun. You can just do this, put one there, and now we can jump up there. There we go. So all fine and dandy. So, okay, yeah, bitmap tile select. So what that will allow us to do is, right now we have to hold T, and then I use the arrow keys. This is how it flips to the tile map. It's very difficult to work with it this way, because sometimes I really can't find the sprite that I'm looking for. So the bitmap tile selector will allow me to, let's see, I'm not sure how I want to implement this, but the idea is, maybe if I hold control, and maybe if I right click, I'm not sure how I'm gonna do it. Maybe pressing T. You know what? Okay, yeah, T seems like a good idea, since we used to access it before with that. So yeah, once you select the tile, you can see how you can just place tiles using that specific one that you selected. So I think, yeah, so T would bring up a box here on the screen about the size of the, it would eventually, let's see, I don't know if I should, it would basically render, let's see, a box here that would, uh, we would have to somehow gray out this scene. But the box inside will have basically the sprite sheets. It would be something like this. So here's that specific sprite sheet. So you can see how all these little tiles belong in there. So if we implemented this feature, we would get, this is what I want to have. I want to have like a box like this. So we hit T and this appears. And then we can actually select a sprite from here. Okay, like, hey, we want to use that one. And we click it and it's automatically, boom, it's automatically part of our tile. And then we can use that. So that's going to make editing levels way, way easier. But then it gets more complicated when you start adding. I want to use the same feature. For example, hitting F will allow me to assign a flipbook to a sprite. That is the next feature that we get into, which is around right here. It's not in research, but we're going to mark it as in research because we're going to have a feature blowout real soon here. So assign flipbook via developer. So the idea is, for example, this specific sprite back there that you can see it's flashing. It's flashing because that specific sprite, we want it to be, it's saying, hey, there's two frames assigned to that. If we take a look at the sprite sheet again, you can see here one that's not lit and one that's lit. And a flipbook basically means we're cycling the bitmap and that specific sprite. 1, 2, 3. We can choose now. The way we choose which sprite to select is 0, 1, 2, 3, 4, 5. So this would be 5, 0, 1, 2. So this would be 5, 2. I mean, this would eventually be 0, 1, 2, 0, 1, 2, 0, 1, 2, 3, 4. So okay, so this would be. It would cycle between 4. It would be okay. So 4 would be the x. So it would go 4, 5, 4, 5, and then it would say 1, 0, 1, 2. So this would be 4, 2, 4, 2. 4, 2, 5, 2, 4, 2, 5, 2, 4, 2, 5, 2. So it's basically the X and Y setting. If we went here, we could probably find this flipbook. And I'm pretty sure that that's how it's assigned. There you go. Right here. 4, 2, 5, 2. So that's what we're doing. We're just adding a sprite. And if we wanted to add a secondary sprite, we can very easily do that. First, we must increase the size of the flipbook to 3 to have it have 3 entries. And then we simply just create another entry here. And then, of course, we need to increase the array number. And now we can choose what sprite we want to add from that list. Let's see, how about, oh, this is not going to make it seem realistic, but let's see, how about, let's say we wanted to add, how about that one? So that one would be 0, 1, 2. So it would be 2, 0 because it's 2, 0. So it would go, you know what, let's do that one. It's that gray looking one. So 0, 1, 2, 3, 4, 5, 6. So 6, 0. So we would put 6 here because that's how many steps we want to move to the right. And then we want to put Y as 0 because this is the row that it's on. So this would be the column. This is the row. So now by doing that, we also have to put 2 there. By doing that now, we added a third sprite to the flip. So now when we go back to the game, you're going to see something. We're going to see something a lot different there. We're going to see that tile that we selected. So you can see right there how it's now selecting that tile. So that's how we add tiles. So the idea is now that once we're in this developer mode, um, we can either hit, if we were to hit F, um, we would again get the same box as before. We would get something like this, and then we can actually choose. If we click, we will be able to choose to add a flipbook to that specific sprite. But this is also a very complex feature, because the idea is that, let's say we have that sprite selected. Now, every time you add a flipbook to a sprite, it automatically overwrites the original sprites. So if we wanted to create, let's say, one that flipped through all of these tiles, we would click 1, 2, 3, 4. But then, of course, if you make a mistake, then I also have to take that into account. So that's a feature that I want to add, so we can have different sprites and things. So that would also work for objects as well. Let's see, what's the next one? Bitmap tile selector, object layer mode, and object class inject. There's a lot of features here that are closely related. So this next part is going to be tricky. There's a ton of features to add here, and they're really going to somewhat finalize the game engine, so to speak. Also, this temporary object layer is yet another layer that I don't know how we're going to add this yet, but let's say an enemy fired a bullet at the player, or we had several bullets, basically anything that flies across the screen and is not meant to stay in the screen is what we would call it a temporary object. Like if an enemy fired a bullet, obviously the bullet may or may not hit the player, and it would disappear. It's not available anymore. So we delete that sprite. So I don't know how we're gonna implement it, but I think that we may have to have a separate layer for that, and we wouldn't need to put it in grid zoning, because it's not something that lives in that layer. It's just a temporary object. So that's another thing to implement. This, I don't even want to get into this one. This is, if you've ever played Sonic the Hedgehog, you'll realize that there's curved surfaces. This is a whole different beast. This probably will not get implemented until the very end of the project. When I have like everything working, this is going to be more like an eye candy feature. Like, hey, let's see if we can get this to work or not. But it would be nice to have sloped or in curved surfaces, and I know how I'm going to do it, but the implementation is very a little complex, so we're not going to mess with it now. So the other thing is object layer mode. So we're able to select between different layers here: layer 0, layer 1, layer 2, 3, 4, 4, and 5. You see, there's a ton of layers. There's 5 layers on this thing. But the layer that we cannot access right now is the object layer, and that is the layer where these objects live, like the player sprite, the moving platform. So when we're in this layer, is how we're going to be able to select those objects and work with them. Like if we want to, once we're in object layer, is how we're going to choose how we're going to add an object to the game. And then when we create an object, every object needs to have a class associated with it. We can't just simply drop an object here. We have to say, okay, is it, what is it? Is it a trigger? Is it a player? Is it an enemy? Is it a moving platform? Is it a spike? So even though we can go in and add these spikes to the actual level like this, it's not the best way to add them. It's best to add them as objects, because these spikes are actually triggers. So when the player steps on them, this object detects our player sprite, and it sends a message saying, hey, you just stepped on me. And then the player chooses whether or not to react to it. In this case, see if when I step over it, the player flashes. So if the whole thing was implemented right now, we would maybe take a life from the player, or the player dies if it doesn't have enough lives, etc., etc. So we're in object layer 5. Every layer is different. For example, layer 0 moves a bit slower depending on how you design it. Layer 5 is basically a really close-up foreground layer. So the way it works is, let's go here. If we were to put something here, let's see. If we were to put something, you can see it moves very, very fast. So we're going to put it over here. And I'll just show you right now, this layer goes way down. It's better when we do this. So the way we add perception to the game is, you can see how this layer is in the front. That's the way that's why it's there. It's meant to add depth, perception to the game, because this object appears closer to us, because when we move, it's right in front of us. So if we were playing, if we were really designing a map, this is where we would put anything that would be in the front. This is a very exaggerated example here. I'm going to go back up here and maybe add just something like that. Maybe you have some kind of thing over there. I don't know. But you can see how that appears way closer. Appears way closer. And that's on that 5th layer. Then we have the main layer, which is this one. So, okay, what were we talking about again? Yeah, the object layer. So this is what we would implement on the different classes for the objects. And again, that will allow us to make much better looking maps, because right now we have to manually go in and add these by hand. So I want to be able to add them through the developer mode, so that we can save and load levels. That's why I've decided to not implement saving and loading maps yet until I have all of this stuff working. So that's going to be that feature. I really got to sit down and figure out how I'm going to do this, because this is a tricky one. This is really a tricky one. So I think that's about it. Yeah, that's about it. Yeah. So that's what I'm going to be working on. I think the first thing that I'm going to implement is the tile selector, because if I'm going to implement these things, I need the bitmap tile selector to work, because that's going to be used when we cycle through the tile layers, and it's also going to be used when we assign flipbooks. So that's the next thing I'll add: assign flipbooks and the tile layers. I'm going to get that working, and then once we have that working, the rest will be a little easier. And then of course we can start on. I think that we can. Yeah, once we have that, we can work on the object layer mode, and once that is implemented, see that one's easy to implement. All you have to do is just activate the layer by pressing O. Let's see. So yeah, this is what I'll be doing next is definitely the bitmap tile selector. And then once I do that, I can work on this feature, assign flipbook, assign the flipbook. So I think that's going to be really cool because I have some artwork that I want to get in, like a piston that moves up and down. Um, if you ever play Sonic, you'll see that there's a ton of stuff that moves in the background. Yeah, so that's what I'll be working on next. So the next update I will have, I don't know when it will come. These two features should be working. So that is what we will see on the next update, the bitmap tile selector, which will be something that looks like this. But this will be in the actual game. Let's see here. Let's get it to the original size so we can. Wow, it's huge. That's huge. So I don't want to mess around with that. So it will be something like this. This will sit inside the game. We may need to resize it. So I know how to do that. It's not that heavy, but I don't want to. Maybe the quality might reduce when we do that. So the idea that we will get a box like this when we hit T, and we'll be able to select tiles from it. That is the first feature. That's what I'm gonna work on next. And then after that, I'll implement adding flipbooks, and that's I'll click on something and we'll see a 1, 2, 3, 4, 5, etc., etc., etc. And we will only add as many as the tile bitmap holds. If there's 100 here, we can add 100, and we will just cycle through all those. Then, of course, is once we assign a flipbook, there's that whole thing about allocating memory for it. And all that gets tricky. So yeah, tile selectors next. Anyway, that's all I got for now. Since I'm going to be working on the tile selector, I'm going to say that it's in progress right here. And I will begin writing down ideas for that. I may make an update of just the tile selector working, and then another one when I have the flipbook working. So that way we can. So I'll probably have it working by maybe next week. So let's close this up. Let's go ahead and let's have another go at the sound system here. Let's turn this to true, because I think last time when I did this, the audio wasn't that loud. Okay, let's have a stab at it here. We're going to increase the volume in OBS, because I think that is what happened. So we're going to go ahead and compile and launch. Okay, so we should be hearing audio right now. Okay, set that to false. I may also add another sound effect when the player gets hurt. Maybe something like "ouch" or "oh." I don't know. We gotta sit down and just mess around. So that's the update I got for now, guys. Thank you so much for watching. And we got, as you can see, we've got many exciting things coming. So if you haven't subscribed, subscribe yet, and stay tuned. So what I'll be doing now is SpaceX is going to be doing a presentation of their Starship. So I am going to go watch that. So that's going to be really cool. So anyway, stay toasty. See you later, guys.